Inequalities. Inequality signs come in four different ways. We have greater than or equal to, less than, and less than or equal to. Let's start with x is greater than a. Suppose we had x is greater than the number 2. We can represent that through a graph using a number line, writing down the number 2, and shading in the region for the solution of x. Since x is greater than 2, we can shade to the right of 2. Remember, on the number line, to the left of 2 would be 1, and to the right of 2 would be 3. Now we have to consider all the values of x that are greater than 2, including 2.1, 2.001, 2.0001, really any value to the right of 2 that gets infinitely close. One way to represent that is to use a parenthesis right on the number 2. This tells us that 2 itself is not a solution, but everything greater than it is. Another way to represent the solution is through interval notation. I'm going to go ahead and write this one out. When using interval notation, we have a starting and an end value. If we look at our solutions from left to right, we can see that our solutions start right around 2. But 2 is not included, so then we'll use a parenthesis. Now the solution goes on forever to the right. We can think about that as going off into infinity. But you can never actually reach infinity, so infinity itself is not included. We always use a parenthesis at infinities. Let's move on to x is greater than or equal to a. Let's say x was greater than or equal to negative 2. Well, once again, we can represent this solution using a number line and graphing our solution. Let's go ahead and put our value number 2 there. And remember, to the left of negative 2, we have negative 3. And to the right of negative 2, we have negative 1. It's a little helpful to write out some other values other than the one that you're focusing on. Now, x is greater than or equal to negative 2. That means any value to the right of negative 2 is a solution. But what is happening at negative 2? Well, that little bar down below is the or equal to part of this inequality, meaning it can be equal to that value of a, or in this case, that value of negative 2. To represent that, we can use a closed bracket. Just a bracket here, opening up in the direction of the solution. Using interval notation, that would look like this. Bracket, negative 2, comma, infinity, parenthesis. A bracket at negative 2, since negative 2 is included in the solutions, and a parenthesis at infinity, because you never really reach infinity. Scrolling down to x is less than a, suppose we had x is less than 3. Once again, we can represent that on a number line and graph our solution. To the left of 3, we have 2. To the right of 3, we have 4. Our solutions are all of the values x that are less than 3. So all of the values to the left of 3 would be included in the solution. Since 3 itself is not included, we will once again use a parenthesis. In interval notation, remember we go from left to right. So if we are looking at our solutions from left to right, we can see that our solution this time starts off into negative infinity, all the way to the left. If that were to continue, we would eventually get into the negative numbers and off into negative infinity. Now, from left to right, our solutions end at 3. Remember, parentheses always at infinities, and since 3 is not included, we will use a parenthesis at 3. For x is less than or equal to a, suppose we had x is less than or equal to 0. Once again, we will use a number line to graph the solution set. To the left of 0, we have negative 1. To the right of 0, we have 1. X is less than or equal to 0, so we will shade everything to the left of 0. All those values are less than 0. But once again, 0 is included. We have the or equal to part, so 0 is included. And we will use a closed bracket there, right on 0. In interval notation, we would read this from left to right. All the way to the left, we have negative infinity, comma, 0. 0 is included, so we'll use a bracket to the right of 0. Now, there is a multiplication property of inequality. It essentially states that multiplying both sides by a negative number will flip the inequality sign. So let's show that in an example. We know that 5 is greater than the number 3. But suppose we multiply both sides by negative 1. Negative 1 times 5 is negative 5, and 3 times negative 1 is negative 3. Well, now we can see if we compare negative 5 and negative 3, negative 5 is less than negative 3. And so that inequality sign changes direction. This will come in handy when we're solving inequalities. Suppose we had negative 2x is less than 4. When it comes to isolating the x, we would have to divide by negative 2. Remember, division is a form of multiplication, so we would still use this rule. Dividing by negative 2 from both sides, we end up with x and negative 2. But let's not forget to change the direction of that inequality. We would now have x is greater than negative 2.